For today's video, we'll be talking about which acid is stronger. And so to have a stronger acid, the pKa must be lower. The lower, the stronger. So for example, we had HCl, and we were comparing it to H2SO4. So first we would determine its pKa. Well, they'll give you the pKa. For the HCl's pKa is -7, while the pKa for H2SO4 is -9. So the lower the better, and H2SO4 is a stronger acid because it has a lower pKa. Okay. Try one more example. So if we had another acid, HI, okay, comparing this to HNO4, NO3, HNO3, the pKa for HI is -10. HNO3's pKa is -1.4. So the lower the better. In this case, HI is the stronger acid because of the lower pKa. Now let's say if we weren't given the pKa and we had to determine it by just looking at the molecule. So there are rules for this, okay? The first things first, okay? Strong acids form stable conjugate base, while weak acids form unstable conjugate base, okay? We'll go through that more detail later, okay? But here's a good rule to remember. The second rule is electronegative elements are more stable. So this means things like fluorine, chlorine, oxygen, they're more stable, okay? Whatever on the periodic table that goes up and right on the periodic table is more stable, okay? So more resonance makes it more stable. We'll get into that later. And less p orbitals are more electronegative, so meaning like hybridization, like sp, sp2, and s are more stable than sp3. Okay, the lower the s, no p's, the better. Okay, it makes it more stronger and stable. Okay, so these are rules for it. Okay, so if I had an example like this. You had H3O. And you're comparing this to HCl, okay? And you were asked which one's more acidic. Okay, so acidic means more which one's more stronger, a stronger acid, okay? So the rules that we look into is electronegativity, okay? So we have oxygen, which is electronegative, but chlorine is way more electronegative than oxygen, okay? So thus making it having HCl be the more stronger, more acidic element in this case. Let me try another. So if we have this molecule right here, okay, positive charge, and we were comparing this to and we were asked to compare these two molecules and see which is more acidic, right? So in this case, we only have one oxygen compared to 1, 2, 3, 4 oxygen over here, but also comparing it to sulfur, which is way more electronegative than oxygen. So in this case, this compound is more acidic than the other one on the left. Now, what if we were given an example, just a little bit more complicated, a little different from the other one? We have the structure right here. Right, and we had to compare it to the structure bottom of this. Okay, so the first thing we want to do is just draw a general base for it. Just test it out to see the conjugate base, because see the conjugate base of it, we'll see which is more stable, because stable conjugate base has the strong acids, so strong acids form the conjugate base. Just draw a base, general base, right? Lone pairs. Okay. Now these lone pairs go on top of this hydrogen, while this hydrogen's electrons give off and make a lone pair with this carbon. So you have the result of looking like this. Okay. Same thing on the top. So this lone pair goes on top of this hydrogen. This hydrogen electrons give off to this oxygen to form three lone pairs. And two lone pairs of oxygen. Okay. So the question is, which one of these acids are more acidic, right? So to see what's more acidic, we have to see its conjugate base. So now we have this conjugate base, right? It's on the right and it's on the left, okay? So for the top one, we see that there's two oxygens, right? So oxygen is an electronegative element, okay? On the bottom, we see an oxygen and a carbon, right? Carbon is electronegative, but oxygen is more electronegative, so there's only one oxygen here compared to two over here. So this right here, this is the more, more electronegative elements make it more stable. So this is more stable than this right here, because of the two oxygens making more electronegative, right? So strong acids form conjugate base, stable conjugate base. So in this case, this right here is the stronger acid because it has a stable conjugate base because of the oxygens, okay? But also oxygens is an electronegative atom. Electronegative elements like to carry negative charge, okay? See right here, the carbon does have a negative charge, but oxygen is much more electronegative than carbon. Now, what if we were given an example just a little bit more complicated, a little different from the other one? We have the structure right here. Right, and we had to compare it to the structure bottom of this. Okay, so the first thing we want to do is just draw a general base for it. Just test it out to see the conjugate base, because see the conjugate base of it, we'll see which is more stable, because stable conjugate base has the strong acids, so strong acids form the conjugate base. Just draw a base, general base, right? Lone pairs. Okay. Now these lone pairs go on top of this hydrogen, while this hydrogen's electrons give off and make a lone pair with this carbon. So you have the result of looking like this. Okay. Same thing on the top. So this lone pair goes on top of this hydrogen. This hydrogen electrons give off to this oxygen to form three lone pairs. And two lone pairs of oxygen. Okay, so the question is, which one of these acids are more acidic, right? So to see what's more acidic, we have to see its conjugate base. So now we have this conjugate base, right? It's on the right and it's on the left, okay? So for the top one, we see that there's two oxygens, right? So oxygen is an electronegative element. Okay. On the bottom, we see an oxygen and a carbon. Right. Carbon is electronegative, but oxygen is more electronegative. So there's only one oxygen here compared to two over here. So this right here, this is the more more electronegative elements make it more stable. So this is more stable than this right here because of the two oxygens making more electronegative, right? So strong acids form conjugate base, stable conjugate base. So in this case, this right here is the stronger acid because it has a stable conjugate base because of the oxygens. Okay, but also oxygens is an electronegative atom. Electronegative elements like to carry negative charge. Okay, see right here, the carbon does have a negative charge, but oxygen is much more electronegative than carbon. So now what happens if we have a molecule that is way too complicated, bigger than the other ones that we can't figure out? So for example, if we have this molecule right here, okay, two oxygens here, and we were comparing it to and then hydrogen here, okay? And the question was, out of these two, which is more acidic, okay? So the first thing we want to know by the rules is to know which one's more stronger. We got to find the conjugate base because more stable conjugate bases forming has a stronger acid. So stronger acids form a more stable conjugate base. Okay, I'll get into that later. Okay. So now what we do is draw the conjugate base for this, right? So we just put any base, put lone pairs, put the negative charge going on. So this lone pair goes on the hydrogen, while this hydrogen gives off an electron to here on that carbon to form this molecule right here. Okay. The negative charge right here. Okay. So same thing on the right side. Base, negative charge, right? Now this lone pairs, start from lone pairs, go on the hydrogen. While the hydrogen got attached, this electron from the hydrogen goes on this carbon right here, forming a lone pair. Okay. Okay. Now for this, we see something. We see that we can do resonance for this because there's a double bond. So the sp2 hybridization, that means we can do resonance for this. So for the first molecule right here, we see that we can go left and right because both are the same, technically the same molecule if you drew a line right down the middle. So let's just go left for the sake of this. So start from the lone pair, right? It forms a double bond right here. Right when you do this, this double bond goes on top of the oxygen, making a lone pair. So we would have this structure right here. And this oxygen would have 3 lone pairs, which gives off a negative charge. There's a double bond right here, and this oxygen stays the same. Okay. Now we can do one more thing, right? We can move one of the electrons, lone pairs on this, forming a double bond. But this double bond moves over here, forming a double bond right here, and then we have to not have carbon 5 bonds. We move this double bond on top of this oxygen right here, forming a lone pair. So it will look like this. So now this oxygen has 3 lone pairs, giving off a negative charge. Okay, there's a single bond. Okay, and this oxygen goes back to normal, 2 lone pairs, and there's a double one right here. Okay, so in total, there is a total of 3 resonance structure. The top one does not count. Okay, 3 resonance structure for this. Now the same thing for this. You see that this lone pair right here can go on top of this, forming a double one right here for that. And then this double bond can form a lone pair for this oxygen on top of that. So it'll give off a structural formula for this. Yeah, negative charge, and there's a double bond right here. And nothing else can be done further. Everything else is a sp3 hybridization. So we have a total of 2 resonance structure. So according to our rules, having more resonance structure means it's more stable. So this, on the left side, we have 3 resonance structure. On the right side, we got 2 resonance structure. Okay, so having more resonance structure means it's more stable. But also, we have on the left side, we have on top of that, we have 2 oxygens. Compared to this is 1 oxygen. So oxygen is an electronegative element, so meaning more electronegative elements, the more stable it is. Okay, so this has 2, well, technically has 3 because of carbon, but we can say 2 oxygens here. And we have 1 oxygen here. Okay. So having more oxygen means more electronegativity, and more electronegativity means it's more stable. So in fact, this conjugate base on the left is more stable. So that means strong acids form stable conjugate base. That means this acid on the left is a stronger acid, so it's more acidic. Okay, because strong acids form stable conjugate base. Okay.